So we're given our three different expressions, right? For expression A, we've got negative 5x plus 8y minus 3 plus 7z. Expression B says 6x minus 2y plus 4z. And expression C says 12y minus 8x plus 2y plus 9 minus z. So we want to know for question number 1, which expression has a 2 as a coefficient? Now remember, when we say coefficient, and I'm going to go ahead and highlight that word again. Yesterday we talked about it, highlighted it in our green before. But remember, a coefficient is attached to the variable. It is attached to the variable. So we are looking for the expression that has a 2 as a coefficient. So let's take a look at expression A. Do either one of these variables have a 2 attached to them? No. What about expression B? Do either one of these have a 2 attached to them?
Yes.
Yeah. But is it a positive 2? No. Remember, this needs to be a positive 2. That is not a positive 2. This right here is a negative 2. That is a negative 2. It's not the same as a positive 2. So the only one that's going to work is expression C. Expression C has a positive 2 as the coefficient. It has a positive 2 as the coefficient. So we've got expression C is going to work. Okay? Problem number 2. Which one of these expressions has no constant? So now remember, a constant is a number by itself, right? It's a number without a variable. So we're looking for the expression that has no constants whatsoever. Which one has no constants? Jaden? Okay, so let's look here. Negative 5 has a letter, right? 8 has a letter. Negative 3 doesn't. So negative 3 is a constant. Negative 3 would be considered a constant. We want one that has no constants. Okay? Jacqueline? B. B is the only one that has no constant whatsoever. Okay? 6 is attached to a letter. Negative 2 is attached to a letter. And 4 is attached to a letter. So we don't have any constants here. So this would be answer choice B. All right, which expression has 4 terms? Remember, terms are separated by plus and minus signs. We're looking for what's separated by plus and minus signs. I'm going to write that down real quickly too. Terms are separated by plus and minus. Okay, they are separated by plus and minus signs. Which one of these expressions has exactly 4 terms? Addison? A. A has exactly 4 terms, right? If we're looking, negative 5x, that's our first term. Positive 8y is our second term. Negative 3 is our third term. And positive 7z is our fourth term. Okay, for problem number 4, I want to know what is the constant in expression A. What is the constant in expression A? Rajay? Answer to number 4. The constant. Constant. That's the number that's by itself with no negative 3. Negative 3 is going to be our constant. Don't forget the negative sign. You must include the negative sign. Okay, the minus sign belongs to that 3. If you don't include it, then that's going to hurt you. Okay, it'll get you the wrong answers. It's going to be really important, especially when we start doing today's work, because those minus signs travel with their term. All right. What is the coefficient of the last term in expression C. So we're taking a look at expression C. We're looking at the very last term. What is the coefficient of it, Noah?
2y.
Well, 2y is not the last term, is it? What's the last term? Our last term is minus z. So what's the coefficient there, Sabina? -1. Guys, if it's not written, see, if you turn around and you look at the back board over there, where you see invisible math, the bottom row, one of the purple papers, it says every variable has a coefficient of 1. So if it doesn't have a coefficient there, then it's a positive 1. Just the same as at the top row in purple, it says every negative variable has a coefficient of -1. So if it says negative x or negative z, then the coefficient is -1. There's an invisible 1 that exists when there's not a number written. So our last term has a coefficient of a -1. Our last term is going to have a coefficient of a -1. All right, now we're going to evaluate. We're going to substitute the values of w equals 0, x equals 3, y equals -2, and z is equal to -5. We're going to evaluate expression C. We're just focusing on expression C. So instead of me doing 12 times w, I'm going to do 12 times what? 0. I'm going to do 12 times 0 because we're replacing w with a 0. All right, instead of me saying minus 8x, it's going to be minus 8 times what? 3, because the x is a 3. Instead of me saying plus 2y, it's going to be plus 2 times -2, because our y is a -2. Okay, and instead of saying minus z, I'm going to say minus what? -5. Minus -5. Okay, so then we're going to go ahead and we're going to plug all of that into our calculator and just hit enter. Okay, if we do 12 times 0 minus 8 times 3 plus 2 times -2 minus -5, what will we get? -14. -14. So our final answer there is -14. Okay? All right. So now what we're going to talk about today, we're going to focus, we have to use that terminology, knowing what a coefficient is, knowing our variables, knowing our constants. We're going to focus on the concept called like terms today. And how like terms works, when you have a like term, you're saying that you have something in common. So when you're friends with somebody, you typically are friends with them because you guys have some commonality, right? Maybe you both like, certain books that you read, or maybe you both like certain movies that you see, or you're both in a certain sport. Okay? You have something in common. It's the same thing for algebraic expressions. Like terms has things in common. Please hand the calculator back to him. Thank you. Okay? When we're talking about what they have in common, they either have a variable in common, and the variable is to the same exponent, or they have absolutely no variable whatsoever. So that would make them in common too, because they have no variable. That would make them both constants. Okay? So when we're taking a look here, I can automatically say that 7, the number 7, is a like term with the number -8. The reason I can say that they are like terms because they are both called constants. So 7 and -8 are like terms. They're both constants. So I could actually combine them together. I could do 7 plus -8. I can combine them together to simplify them to one value. 4x has a like term. 4x is going to have a like term with negative half x. Even though one of them's positive and one of them's negative, one of them's a fraction, one of them is not, they both are like terms because what do they have in common? The variable on the side, right? They both have the same variable. They both are variables of x. Okay, so 4x and negative half x are like terms because they both are x. They are like terms because they are both x. Okay, and I'm not going to highlight over the 2y because my highlighter for some reason is really dark. But negative 2y is a like term with 0.6y because what do they have in common? They're y's. They are both terms of y. Even though one of them is a negative whole value and one of them is a decimal, they are considered like terms because of their variable. Their variable is in common. So when we are looking to combine like terms, we are looking for commonality, common variables that they share. So let's take a look at problem number 1. I have 4x plus 3x. First thing I need to ask myself, are they like terms? Yeah, they are. They're like terms because of the fact that they both have terms of x. So this means I can combine them together. What do you think it's going to equal if I say I'm doing 4x and I'm adding 3x? What do you think? 7x, right? Because all you are physically doing in this situation is you are looking at their coefficient, the number that's in front of them, and you are combining them together, those numbers together, and you're letting the x just tag along. Okay, so you're really just focusing on doing 4 plus 3, and you're attaching the x at the end. So that would equal 7x. And if you need to look at it visually, if I say, oh, I've got 4 x's, well, I'm going to draw 4 x's. 1, 2, 3, 4. And then I want to combine it with 3 x's, so I'm going to add 3 more x's. 1, 2, 3. And so now I have a total of 7 x's. So 7x would be my final answer. Now remember, I said it's very important that you know the sign travels with its term. The sign travels with its term. Because when we're looking at number 2, we have 3x plus 6 minus 8x. What are my like terms here? Kamari, turn around. What are the like terms here? John Carlos? Huh? Okay, so really close. He did say 3x. 3x. But the problem is he said only 8x. But the sign travels with the term. So what sign is going to travel with the term? Negative 8x. Yes, that minus sign is going to travel with that term. That's the biggest mistake I see every year, is that people look at it and they go, oh, it's just 3x and 8x, that's 11x. But it's not 3x and 8x. It's 3x minus 8x. So you're not adding them together, you're subtracting them. You're doing 3x minus 8x. So we're really doing 3 minus 8 and then attaching the x at the end. Now keep in mind, look at the order. You're taking a small number and subtracting a large number. So what kind of value are you guys going to get? A negative. Okay, so what's 3x minus 8x, Jaden?
5.
Negative 5. Negative 5. So we get negative 5x. Now, what about the 6, though? The 6 is all by itself here. Does it have any like terms that I can combine with it? No. So do I just ignore it and not put it anymore? No. I still have to make it part of the problem. Notice that's why I'm going to put it in a different color so that you guys realize that they cannot be combined together. That's mistake number 2 I see every year. Everybody goes, okay, well, negative 5x plus 6, well, negative 5 plus 6 is 1, so I have 1 or 1x. But you can't combine them together because they are not like terms. They are not like terms, so therefore they cannot be combined. That would be your final answer. Negative 5x plus 6. Okay, let's take a look here at number 3. We have negative 2y plus 4x plus 2x plus 7y. Okay, so I've got several terms. Let's find some like terms. Let's start alphabetically. So in alphabetical order, which variable am I going to start with? Y or x? If we're going in alphabetical order, are we going to start with y or with x? X. It's x, y, z, right? X, y, z. We're going to start with x. So let's take a look at x here. We've got a positive 4x. Remember, I'm including the sign that travels with the term. What's a like term with positive 4x? Rajay? Positive 2x. Okay, so they are like terms. So I'm going to go ahead and write them together. I've got 4x that's positive, and I'm adding 2x with it. What is 4x plus 2x? Nihat? 6x. Okay? All right, I have a negative 2y. Do I have a like term that goes with negative 2y? What's the like term? Jalen? What's the like term that goes with negative 2y? Positive 7y. This positive 7y is going to belong with the negative 2y. So we're going to take negative 2y plus 7y. Oops. Negative 2y plus 7y. Well, what's negative 2 plus 7? Positive 5. So we have a positive, and I love that you said positive 5 because that means I'm going to put a plus sign here, a positive 5y. Can I combine those together? No. They're not like terms. One's an x, one's a y. So that is our simplified expression. Kaden, turn around, babe. That's our simplified expression. 6x plus 5y. Okay, we're going to pause. Put it away. Number 4, we've got n minus 4 minus 9n plus 7. Again, we're looking for our like terms, so that we start with the variables first. Patrick, throw it away. We're starting with the like terms first. Our first like term is n. Our second term to go with it is at minus 9n. Now, we don't have a coefficient written in front of the n, but what did we just talk about? What is invisible that exists there? What value? A 1. So this is a 1n, and we're going to subtract a 9n. We've got a 1n, and we're subtracting a 9n. So we're essentially just doing 1 minus 9, and then attaching an n at the end of it. What's 1n minus 9n going to give us, Rajay?
Negative 8n.
Very good. Negative 8n. Negative 8n. Okay, so then we look at our negative 4. Negative 4 has a like term, right? Because it doesn't have any variables whatsoever. So it's a like term with positive 7. Negative 4 and positive 7 are considered to be like terms. So we can do negative 4 plus 7. So in your calculators, you could type in negative 4 plus 7, and we would get a positive 3. So I have to put the positive sign and the 3. Now, I want to make sure you guys understand something. I'm very much aware of the fact that your calculators have letters on them. So let me show you. I know that your calculators have letters on it. However, you cannot type those letters into here. So if I were to type 4x plus 3x, if I do 4, and then here's my x, if I do 4x plus 3x, it's not going to show me 7x, it's going to give me a 0. No matter what you do, every one of those answers that we have here is going to come out to 0. So if I do 3x plus 6 minus 8x, if I do the 3x plus the 6 minus the 8x, it's going to make all of my variable terms come out to 0, and then it's only going to leave me with my numbers. So you need to be mindful of that. Do not type letters into your calculator. Do not type letters into your calculator. It will not work it out for you. You need to understand how to combine those like terms yourself. Okay, so problem number 4, we got negative 8n plus 3 as our final answer. All right, I want you guys to flip it on over to the next page. I want you guys to try and do problems, let's see here, 5 through 10. You're going to try problems 5 through 10 on your own. Minus 11, right? 12x minus 11 for problem number 5. Okay, so we've got to look at the like terms. We've got a negative 3x and a positive 15x. So I can rewrite those. Guys, this is one of the reasons why I do things in color, because it kind of helps you see that these are the like terms. Jalen, kind of helps you to see that these are the like terms. Now, like I said, you can't just type negative 3x plus 15x into your calculator. Okay? If you do that, you're gonna get a 0 out for those answers. It doesn't take the variables. But you can type negative 3 plus 15 and then just put your x at the end of your answer, which would give us 12x. Okay? Then we've got our constants, our negative 9 and our negative 2. So when I rewrite that, it looks like negative 9 minus 2. Okay, negative 9 minus 2 comes out to a negative 11. So then there's my final answer. If you want it all in a solid color, it's just 12x minus 11. That's your final answer. Cannot combine those together because those are not like terms. So it's as simplified as it's going to get. Okay, problem number 6. For problem number 6, what did you get? Rajay?
I got negative 1 and positive and 0 for 7y minus 8, minus 8y.
Okay.
Negative 11 plus 11.
Okay, so close, but we still have that positive 12 as well, right? So let's take a look here. The first one that we're focusing on, we're going to first focus on that negative 11x and the positive 11x. Okay, a negative 11x and a positive 11x are just going to come out to 0x. So if it's 0x, do I need to write it? If it's 0x, do I have any x's anymore? No. So I no longer have an x anymore. I don't have to worry about it. Then we have our positive 7y and our negative 8y. So a positive 7y and a negative 8y is going to come out to a negative 1y. But then we still have this positive 12, that constant that doesn't have anything that's a like term to it, but you still have to write it down. You still have to write it down. So then when you write your final answer, I don't need to write the 0x. I just have to write negative y. I don't technically have to write the 1. Remember, invisible math, a negative 1y is the same thing as just negative y, right? A negative 1x is the same thing as negative x. So I could just write negative y and then plus 12. And that would be my final answer. Okay, problem number 7. For problem number 7, what did you get? Anybody besides Rajay? Anybody else finish besides Rajay? Jalen, what did you get? Anything else?
That's what I got.
Did you type the x's into your calculator?
No. Oh, what is it? 2x.
Not 2x. It should be 9 or 10x. Let's take a look. Take a look up here. For problem number 7, our like terms, we've got a 4x plus 5x. Kamara, are you writing this? Plus 1x. Remember, this x technically has an invisible 1 in front of it. Stop. We're going to do 4x plus 5x plus 1x. When we add the 4 plus 5 plus 1, that's going to give us 10x. Okay, then we have our number terms. We have a positive 7 and a positive 2. A positive 7 and a positive 2. If I do 7 plus 2, that's going to come out to a positive 9. So then when I'm taking a look here, my final answer is just 10x plus 9. 10x plus 9 is my final answer. Okay, what are my like terms for number 8, guys? Jakaylin, what's my like terms for number 8? Very good. 2n and negative 5n. Jalen, I hope you are not on your computer right now when we're doing notes. 2n and a negative 5n. 2n minus 5n. So we're technically just doing 2 minus 5 and we're attaching the n at the end. 2 minus 5 gives us a negative 3, so we're attaching the n at the end. Okay, then we've got a positive 3 and a positive 6. Positive 9. Thank you, Jakaylin. We've got 3 plus 6, which is positive 9. So our final answer is negative 3n plus 9. Negative 3n plus 9. Okay, for problem number 9, we've got a negative 9x plus 2y minus 4 plus 2x. Okay, what's a set of like terms that we have up here? Good. Negative 9 and positive 2x. Good. Negative 9x and a positive 2x. There's a set of our like terms. So we've got negative 9x plus 2x. We can combine those together, and that's going to give us negative 7x. Okay, do we have any other like terms in that problem? No, right? We don't have any other like terms. This positive 2y doesn't have any y terms. This minus 4 doesn't have any other constant terms. So they are just going to stay a positive 2y and a minus 4. So then our final answer is negative 7x plus 2y minus 4. Okay, let's do number 10. Brianna, what is one set of like terms up here? Very good. Negative 7w and negative w. The negative w doesn't have a number there, so what did we say we always put if there's not a number? A 1. Put the 1 here. Put that 1. So we have negative 7w minus 1w. Negative 7 minus 1 and attach a w at the end. That's going to give you negative 8w. Do we have any like terms with our 7x? No. We have no like terms with that 7x, so that 7x is just going to say 7x. Do we have any like terms with the positive 3? Yes. Right? Because positive 3 is just a number. Do we have any other just numbers? Yeah. Negative 8. Negative 8 is just a number. Okay? No variables attached. So we have a positive 3 and a negative 8 that we can go ahead and work out. Positive 3 minus 8 is going to be a negative 5. So we get negative 8w plus 7x minus 5 as our final answer. All right. Go ahead and get logged into your computers.